Because the idea is what? Get rid of z. So you can have just a system of two linear equations of two unknowns, x and y. So in here, elimination method, right? Elimination. I'm gonna eliminate z. Choose equation 2 and equation 3 to eliminate z. So I'm going to add two equations together. I got what? Equation 2. 3x plus y minus z equal to 2x. Equation 3 right here. I got x plus 2y plus z equal to 8. Add them up. Because we already have the numbers for z, the coefficient for z set up, so we don't need to multiply anything. We got what? 4x plus 3y equal to 10. We see what happened in here? We have a new equation with two variables only, just x and y, no z. And what do we do now? We have to choose another pair of equations. We already used 2 and 3, right? Equation 2 and equation 3. Now you can choose equation 1 and equation 3, or equation 1 and equation 2. And you have to eliminate z again, because our bottom line is we're looking for another equation, which is x and y. In this case, I'll choose equation 1 and 2, because I got 2z right here, I got negative z right there. All I need to do is multiply the second equation right here by 2. So I'll get negative 2z, and I'll add them up. Okay. So let's do that. For equation 1, I'll keep it the same. 2x minus y plus 2z equal to 6. For equation 2, I'm going to times 2, because I need negative 2z. I have what? 6x plus 2y minus 2z equal to 4. Keep in mind, I got to multiply everything by 2. Now I'm going to add them up. I got what? 8x plus y, of course z cancels out, equal to 10. You see what? 4x plus 3y equal to 10. Ax plus y equal to 10. What are we getting? We are getting a new system, simpler system of just two variables with two unknowns. And they are 4x plus 3y equal to 10. 8x plus y equal to 10 again. Okay? My curly bracket looks ugly, so let me change it. Okay. So you can do elimination again. We learned that already. We can multiply the first equation by negative 2. We can eliminate x half of y. Or you can multiply the second equation by negative 3. You eliminate y and solve x. Let's do that. Time this by 2. Negative 2. We got what? Negative 8x. Negative 6y equal negative 20. Then 8x plus y equal to 10. Add up. X cancel out. Negative 5y equal to negative 10. So y is equal to 2. Alright? Or now we have y ready. I can time the second equation right here by negative 3. So I got negative 3y, I can solve x. I got 4x plus 3y equal to 10. Negative 24x minus 3y equal to negative 30. So negative 20x is equal to negative 20. Of course, x is equal to 1. Divide both sides by negative 20. After having x equal to 1, y equal to 2, plug into any of those equations, you can solve for z. Let's try to plug into the third one, okay? X is 1 and y 2. So 1 plus 2 times 2 plus z equal to 8. 1 plus 4 plus z equal to 8. Okay, so z is 3. You have the same answer. Okay? So in general, as mentioned before, the bottom line, the whole idea for solving for system of linear equation is you try to reduce the number of variables. Okay? So in here you have 3 equations, right? You choose one pair of equations, you eliminate one variable. You choose another pair of equations, you're going to eliminate the exact same variable. You're going to come up with a new system with less variables. Okay? Say if I got 4 linear equations, you solve for 4 unknown, x, y, z, and t. I choose equation 1 and equation 2. Eliminate t. Right? I'm going to come up with a new equation, which is x, y, z. I can choose equation 2 and equation 3. I can eliminate t again. I come up with a new equation, which is x, y, and z. And I have to choose another pair of equations, say 3 and 4. And eliminate t again. Then I come back with a new equation, which is x, y, z. You know what? We ended up with a system of 3 linear equations, 3 unknowns, x, y, z, and then things repeat. Of course, a bigger system, then you have to read more steps, take longer time, but that is the algorithm. Okay, and this is the end of 8.1. We just introduced you 2 methods to solve a system of linear equations, which are substitution and elimination. Let me move on to the next section for chapter 8, with sections 8.6. You see that we skip all the way from 8.2 to 8.5. It's about matrices, and you guys are going to learn that in pre-calc. So I'm going to follow schedule, okay? It's our college algebra. We do system of linear equation using just substitution and elimination. We don't do matrices yet. Okay, 8.6. We're going to talk about system of nonlinear equation. Nonlinear, okay? And I claim that for system of nonlinear equation, we do not have any general method to apply to all type of problem. For linear equation, you can do substitution for all problems if you don't like elimination, and vice versa. You can do elimination for all problems if you don't like substitution, or you can mix between the 2 methods. You can get to the answer. But for nonlinear equation, you may not have a general rules to apply to all the problems. However, most of the exercises in our course is going to be good with substitution or elimination method. And I claim that it turns out in here that substitution method becomes more powerful because it can be used to solve more problems. Okay? So let me demonstrate this section by giving you a couple examples, because as I mentioned, we don't have any general methods. So just more example, better. Look for the example. Okay, I got a bunch of example right here. Solve for x and y. Example. Solve for x and y. Okay? First example. Negative 3x plus y equal to negative 5. And then the second equation is x squared plus y squared equal to 5. And you see that this system is nonlinear because the second equation right here, we got x squared, right? Power 2. We don't just have a single x. The first equation is linear. 3x, negative 3x plus y equals to negative 5. That's linear, but the second one is not linear. So the whole system make it nonlinear. And graphically, you see the first one is a line, the second one is actually a circle, for your information. So we have a circle and we have a line. So if the circle intersects the line at 2 points, then you may have 2 solutions, or maybe 1 solution, maybe no solution, who knows. Solve this system, we usually use the substitution method, okay? Because I don't know how to multiply the second equation by what number to match up with the first. This is just a single x. The second one is x squared, so it's not the same degree, not the same term. So I'm going to use substitution. Let me solve a y in here. First equation, second equation. Equation number 1, solve for y, I got what? Y is equal to 3x minus 5. You know what I've done? I add 3x on both sides, okay? Let me rewrite. Make sure that everyone get it. Negative 3x plus y equal negative 5. And add 3x on both sides. That's what I've done. Got y equal to 3x minus 5. Okay. Even though I can do elimination, I cannot do elimination, but substitution is okay. I can plug this into the second equation. So for equation number 2, I got x squared plus y squared equal to 5, right? So y becomes 3x minus 5. So x squared plus 3x minus 5 squared equal to 5. no more y in my equation, and I can try to simplify this. Let's see what we got. X squared plus, I have to FOIL this out, right? So 3x minus 5 squared means 3x minus 5 times 3x minus 5. I got 9x squared minus 15x, and minus another 15x, and then plus 25. This is 9x squared minus 30x plus 25. So my equation becomes x squared plus 9x squared minus 30x plus 25 is equal to 5. What we have is a quadratic. Let's try to simplify. 10x squared minus 30x, subtract the 5 on both sides, so plus 20 equal to 0. For quadratic, you try to bring everything to one side, equal to 0 on the other side. Okay? Then I can simplify this a little bit more. Divide both sides by 10. I got x squared minus 3x plus 2 equal to 0. Now this is pretty simple to solve. Factor out or quadratic formula. X minus 1, x minus 2 equals to 0. So x minus 1 equal to 0, or x minus 2 equal to 0. So x equal to 1, or x equal to 2. Now you have to solve for y, right? X equal to 1, then y is 3 times 1 minus 5 equal to negative 2. X equal to 2, y is 3 times 2 minus 5 equal to 1. Okay? So you should really have two solutions in here. X, y could be equal to what? 1, negative 2, 1, negative 2. And the second solution is x equal to 2, y is 1. Okay, here comes another thing that you don't have to do in system of linear equation. But for nonlinear equation, this is you need to do. After having solutions, just call it what? The possible solutions, okay? You have to do one more step. That is to check, double check, make sure those solutions works. Okay, so what solution here? 1, negative 2. Plug into the first equation. X is 1, negative 2. Is that right? 1 here, negative 3 times 1 is negative 3, minus 2, negative 5. Good. 1, 2, 1 squared is 1, negative 2 squared is 4, 1 plus 4 is 5. So this is a good solution. And you do the same for the second pair of solution. If it works, it's good. Sometimes it may not work. Okay? So some solutions is good, some not. So make sure that you check, you double check. And because on the way of solving for system of nonlinear equation, you may square up both sides, and you may lose some conditions on the original system. So you have to check. Okay? I say make sure that you check. Okay? Let me give you another example. See if it worked. How about this? I'll just copy from the book then. Solve for x and y. Have this. X squared equal to y, and the second equation is xy equal to 1. This is my new system. You see, it's not linear, right? You got x squared and you got x times y. So it's really not linear. And again, I cannot use elimination method in here because I don't have any common term to eliminate. But at least I can do substitution. I see the first equation right here, y is equal to x squared. So I'm going to substitute y by x squared in the second equation. I got x times y, which means times x squared, because I know that y equal to x squared is equal to 1. So x cubed is equal to 1. So you say cube root on both sides, and x is equal to 1. Cube root on both sides. Okay? And after having x equal to 1, then y is x squared, is y equal to 1 squared is still 1. This system only has one solution. xy is equal to 1, 1. Looks complicated, but not so hard. Let's try it one more before we move on to another one. How about this one? This is harder. Try this. we have another example. X squared plus y squared equal to 10. And the second equation is xy equal to 3. Okay, have to solve xy from here. And I don't know how to use elimination, but at least I can simplify the second equation. None of those are linear, by the way, okay? But I can solve x and y from here. Say I solve for y equal to 3 over x, and by the way, x cannot be 0, okay? 0 times 2y will never equal to 3. Both x and y are not 0. Then you can, are you okay to divide by x? Because you know it's not 0. You cannot divide by 0. That's why you have to check. So you know that y is x, I'm sorry, 3 over x. Now we can substitute that y by 3 over x into the first equation. So we got x squared plus y squared, which means 3 over x squared equal to 10. Okay? What? X squared plus 9 over x squared is equal to 10. See what we're doing right here? Simplify the second term. That 3 squared is 9, and then x squared is x squared. Okay, how to get rid of a fraction? Multiply both sides by x squared. Okay? Because x squared on the bottom is going to cancel out with the x squared on the top. I got x to the 4 plus 9 equal to 10x squared. Alright, so bring everything to one side. X to the 4 minus 10x squared plus 9 equal to 0. The reason why I wrote it this way because it's kind of similar to a quadratic equation. Okay? If you think of x squared as one term, so this is really quadratic. Then factor this out. X squared minus 1 times x squared minus 9 equal to 0. And this is the tricky step that not many people may see at first. You see x to the 4 and x squared, right? A number is similar to quadratic. Like negative 10, so what? Negative 9 and negative 1. And make it negative 10. Negative 9 times negative 1 is 9. Okay, so you have this. So you really have factor this out. Okay, you got. You can actually factor out more because x squared minus 1 is x minus 1 times x plus 1. X squared minus 9 is x minus 3 times x plus 3 equal to 0. You're going to end up with what? 4 solutions in here for x. X equal to 1, x equal to negative 1, x equal to 3, or x equal to negative 3. And then, of course, having x, you can solve for y. Look in here. X equal to 1, y is 3 over 1, which is 3. X equal to negative 1, so y is 3 over negative 1 equal negative 3. X equal to 3, so y equal to 3 over 3 is 1. Negative 3 for x, so y is 3 over negative 3 is equal to negative 1. You know what? You're going to have 4 solutions in here. 4 possible solutions in here. X, y is going to be equal to 1, 3. What else? 3, negative 1, negative 3, negative 1, negative 3. What else? 3, 1, and then negative 3, negative 1. And keep in mind that this is not the end of the story yet, okay? You are like 80% done from the problem. The last step is what? You have to check to see if any of those solutions really work. It's really working. So what? 1, 3 right here. 1 squared is 1, 3 squared is 9. So 1 plus 9 equals 10, yeah? 1 times 3 is 3, yeah? And symmetrical, so negative 1, negative 3 work. X, Y, as I said, symmetrical. So 3, 1 also works, negative 3, negative 1 works. So it has solved all 4 solutions. Okay. Okay. Let's move on to the next, the last section. This is 8.6 already. I forgot to change. Okay. I'm going to move on to the last section, 8.7. We talk about system of inequality. So you don't see equal sign anymore. This time you see what? Greater than or less than. All right. 8.7. System of inequalities. 8.7. System of inequalities. Okay, next example. Let's start with just one inequality instead of a system. Solve for x and y. I'm going to give you something like this. 2x minus 3y is greater than greater than or equal to 6. Okay? You see what? It's not equal sign anymore. Greater than or equal to. So our job is to find all the value of x and y such that 3x minus 2x minus 3y are going to be greater than or equal to 6. And I claim that with this kind of type of problem, you won't be able to solve using the equation, algebra. You have to do what? Graphical method. Okay? You're going to show your solution on the graph. And most of the time, you're going to have infinitely many solutions. It means that many points of x, y is satisfy this inequality. All right? So here is how we tackle this problem. You try to solve for y. Okay? So what? Try to solve for y. The first step. Try to solve for y. Of course, in terms of x. So I got what? 2x, I mean. 2x minus 3y is greater than or equal to 6. We're going to subtract the 2x on both sides. Subtract 2x on both sides. We have negative 3y greater than or equal to negative 2x plus 6. You see what? If we add and subtract a quantity on both sides, you keep the inequality the same, okay? Now you want to solve for y, you have to divide both sides by negative 3. What happens if you divide by a negative number? You really have to flip the inequality. So divide both sides by negative 3, negative 3, negative 3. I got y, that's what? 2 over 3x. Then minus 2. The sign right here, greater than or equal to, is going to be flipped into less than or equal to. Okay? Divide both sides by a negative number, flip. Now, the second step is to graph that. You see, we have a kind of linear equation that y equal to 2 over 3x minus 2. So second step, graph the line y equal to 2 over 3. I was saying that 3 over 2. 2 over 3, x minus 2. Now let me try to graph the line for you. X-axis right here, y-axis, 2 over 3x. What did I write? Okay? Plug some point. And the y-intercept is at negative 2. 1, 2, 3, 4. 1, 2, 3, 4, 5. 2, 3, 4. Let's use a different color. Negative 2 right here. And the slope is 2 over 3. So rise 2, run 3. This is the second point. You have 2 points. Okay to graph a line. Okay. This is the line y equal to 2 over 3x minus 2. And you see what? This line splits the planes into two halves. The upper half and the lower half. And I claim that what? All the good solutions for this inequality are going to stay on one half. And then the other half of the plane will be non-solution. Okay, so your job now is to determine which half is going to be the solution set. And there are a couple of ways, at least 2 ways as I know, to figure out which half. First of all, you can look at the inequality right here and say y is less than, right? Less than, smaller is going to be the lower half. And if you know that the lower half is good region, you're going to shade it. Okay. The second thing, we only know what? Upper half or lower half is solution. What about the borderline itself? Is that part of the solution? It depends on the inequality right here. If you got what less than or equal, that means what? The borderline is included into the solution set. Then you're going to draw that line as a solid line. Okay. What if I take away that equal sign? Means what? Y going to be strictly less than 2x, 2 over 3x, subtract 2. At that time, you don't draw the borderline as solid anymore. Instead, you have to draw it as a dotted line or dashed line, however you call it. And that indicates that we are not counting the points on the line. We only take the points that strictly below the line for solution set. Okay? Another way of finding the solution set is what? You try a point. You plot a point right here. X is what? X is 0, -3. X is 0, -3. Was that good? X is 0, Y is -3, so it's 9, bigger than 6. This point is good, means